Hi, good afternoon. So in today's introduction to research paper, I'm going to present the effects of syntactic features in automatic prediction of morphology. So this paper was presented in a conference of EMNLP 2 years ago. So as an introduction, the aim or the purpose of this research was to analyze the effect of syntactic features when used in automatic morphology prediction. So the approach the authors chose was to examine the effect of syntactic information when it is integrated into the future model of morphological tagger. So generally, the approach they followed resulted in an improved morphological prediction. So the motivation of this idea was, if in normal, ordinary researches which are done for morphological prediction, most of the time linear context is taken as feature. So in this paper, what they tried to do is they tried to find out the relationship between non-linear words or parts or components of a sentence, specify that syntactic relationship, and use it as a feature for a morphological tagger. So usually this kind of relationship is difficult to capture for linear systems, but if it can be extracted and if it can be used as a feature, they hypothesized that it might increase the performance of a morphological tagger. So as an example, this is a German sentence, and here we have the when translated to English, and here we have regions. So if we see the morphological features here, this is feminine plural in this case, nominative and accusative case. So it agrees with this, with the word which is at the end of the sentence here. So there is agreement between this word, the, and regions. So they are trying to extract this kind of relationship and use it to increase the performance of a morphological prediction system. So they tried to experiment with 4 different languages: Czech, German, Hungarian, and Spanish. So generally, Czech and Hungarian are considered languages with very rich morphology, and German and Spanish show verbal and nominal morphology. So the data set are as specified here. The tagger that they used assigns full morphological description to each token in a sentence. So the tagger and the parser are from a off-the-shelf component which is called mate tools. They used this to tag the sentences, that the data that we saw earlier. So the approach, as I have said, is the parser uses the output of a morphological tagger in its feature set, and on the other hand, the morphological tagger also, which they were analyzing, uses the output of parser as syntactic features. So the syntactic features are added as features for predicting the morphological behavior of the sentences. So for the German and Spanish data sets, they annotated for lemma and part of speech tag on the first pass of the algorithm. So there are 2 passes, as we will see later. So in the first pass, they annotated lemma and part of speech tag using the mate tools, lemmatizer and part of speech tagger. And for the Czech and Hungarian, the data was pre-annotated, so it was not pre-processed. So as specified here, doing morphology prediction as a separate step allows the use of lemma and part of speech information in the feature set. So in addition to other morphological features, part of speech and lemma were added and in the next pass they were used as features also to enhance the performance of the morphological prediction system. So these are the baseline features. Form means word, and 1B and 1A, or the other numbers, it means one token before and one token after. So these are the features that they have used for the baseline. S is for suffix, MP is for prefix, plus is for conjunction. So these are the static features, and these features vary according to the algorithms. And these are specific features that are only found in Hungarian, Czech, and Spanish. So these are the baseline features, without including the syntactic features, only the morphological features. So on these features, they tried to add the syntactic features and see if the performance of the predictor is improving. So these are the baseline. And these are the syntactic features. So syntactic head of the sentence, and leftmost daughter, and direction of the head with respect to the current token. So these were the features that they tried to use in order to enhance the predictor. So all the data sets are annotated with predicted morphology from the baseline system. So using the baseline system, they tried to tag the morphology, and also they added the syntactic information from the dependency parser, which is available in Mate tools. So the experiments were done in 4 different configurations. The first is baseline, where they used off-the-shelf or pre-made morphological tagger, which is called Morphit. And in the second baseline, they used the features that we have seen earlier without the syntactic features. So these are the 2 baselines. And in the third setup, they used full system using the syntactic features provided by the dependency parser. So in the gold experiment, using the gold syntax, they have also used this test for comparing their results with the gold results. So these are some of the results when the syntactic features were added into the system. So for Czech, German, Hungarian, and Spanish, these are for unknown words out of vocabulary, and this is the overall performance. So this asterisk marks the statistically significant results. So when compared to the baseline, this is 92 and this is 93, but it is statistically significant. So we see a little an improvement in when the syntactic features were added with the morphological features. So generally, syntactic features work well with Czech and German, whereas for Hungarian and Spanish there was no significant improvement. So it was 96 and there was no that much improvement when compared to these other languages. But for German and Czech there was a good improvement. So now that they know that there is some improvement, that the system can learn something from the addition of the syntactic features, how about if we compare it with features which are extracted only from lexicon or morphological dictionaries? So they wanted to see which one is more useful in increasing the performance of the system. So lexicons encode important knowledge that is difficult to pick up in a purely statistical system, such as gender of nouns. So this is embedded in lexicons of words, but it is difficult to pick up from a statistical system. So they used morphological dictionaries which have features of gender and other morphological features like number and case, and tried to see the difference in the result. So this is results when the lexical features or the morphological dictionary is used, and if we compare it with the previous result, these results are better than when the syntactic information is added. So the general conclusion was, even with considerable amount of training data, rule-based morphological analyzers are important resources for morphological description, especially for unknown word detections. So why there was improvement in some languages and the other language didn't improve that much in the morphological prediction? So syntactic features helped in prediction morphology of Czech and German, but not in Hungarian and Spanish. So the interesting finding from this experiment was considering agreement. So those languages which show a lot of agreement in different constructors of the language, those knowledge were used in order to enhance the performance of the tagger. So for Czech and German, we see subject-verb agreements, and in noun phrase cases of number and gender also there is agreement. And also for Czech and for German there is this kind of features. But for Hungarian there is only this noun phrase case and subject-verb agreement. So because of this morphological behavior, a little is learned from those languages which does not show that much agreement in their rules, grammatical rules. So these results measure the accuracy on tokens and their syntactic heads. So this is a baseline, and this is when the gold data is used. So here in Czech we see an improvement from 79 to 80, but in Hungarian we don't see this improvement. It is 84, and it's 84 here also, and also in Spanish 96 and 96. The improvement is seen in Czech and German language. So for Czech and German, where form ambiguity is seen throughout the inflectional rules, we see improvements. Because of the inflections, we can learn something from the system. But for Hungarian, the form or the words are not usually ambiguous within one morphological category. So not much is learned from the Hungarian data set. And for Spanish, even the baseline models perform, they have high performance. So increasing the syntactic relationship didn't have that much impact on the data, because even the baseline system can perform well when compared to the gold system. So this is what they have learned from these experiments. When there is agreement between subject and verb and other constructs in the language, then much can be learned, much syntactic information can be learned, and that information can be used to enhance the morphological prediction. So how much syntactic information is actually needed in order to enhance the prediction? So this is one case of German language, and there are also other cases. So this is the x-axis is number of sentences, and the y-axis is accuracy. So as we can see, the graph became flat just at the start of the experiment when the number of sentences is about 1,000. So it didn't show that much performance increment in the accuracy, even though the data is increased. So very small amount of syntactically annotated data are enough to provide parsing quality that is sufficient for morphological tagger prediction. So this was also another point or another conclusion that they have reached. So in conclusion, the syntactic information for predicting morphological information is very helpful, particularly for languages which show morphosyntactic agreement, and small amount of training data may be sufficient to train a statistical parser that will be used by the morphological tagger, and specific features of languages can help in explaining the behavior of automatic tools, as we have seen in German and Czech languages. So this was the conclusion for for the experiments or the research to find out if syntactic information can help to boost the performance of morphological taggers. Thank you very much.